everyone. Welcome back to my math teaching channel online. So in this video, I would like to show you the application of the derivatives. And you will see how useful the derivatives applied in problem solving in all areas. I will upload a file with on the exercise to help you with the practice. However, I would like to show you my solution in the way how we deal with this problem. So I choose some typical question which is involved in geometry problem, in finance, in physics, and each of the problem is a particular in one aspect of life and in another aspect of life in our reality. So to show you, yes, there is a connection between calculus and our real life problems solving. Anyway, so let's get into the first problem I wrote on the board now. And of course, it's the beginning, so I will just choose a very simple question and simple problem. And later on, we will work on more difficult problem with some more drawings and, like in-depth more. So let's see how we deal with the first easy problem. So let's read together. So on the board, I have the problems asked. Find the rate of change of the area when the radius r equals 6 centimeters, given dr divided by dt equals 3 centimeters per minute. So let's work on a little bit. Let's get the drawing. So when they're talking about the area, when r equals radius, so we can imagine that we have a circle with the radius r from here to here is 6 centimeters. And inside is the area of the circle, right? The surface inside. And the question say, find the rate of change of the area when the radius equals 6 centimeters, given dr over dt equals 3 centimeters per minute. So you can imagine this question is about, maybe there is a something with the shape of a round shape, right? Some area with the round shape. And this circle is not stay still, like with the radius 6 centimeters, but over the time, the circle is become smaller and smaller. So it decreases with the rate of radius is 3 centimeters per minute. So in each minute, it decreases by, the rate of it is decreasing by 3 centimeters per minute. So it's just think about like, snowball, but this is, we not apply the three-dimensional, it's just like one round big circle, right? With the radius of 6 centimeters at the beginning. Later on, this circle is changing, it getting change over the time. So the rate of change of it is 3 centimeters in 1 minute, right? So the question asks for, given the rate of change of the radius, ask for what is the rate of change of the area. So what is the rate of change of the area? So the question will ask for, what about dA over dt, right? This is the question. So this is given, and this is a question. Now to solve this kind of question, we're going to have to put in the function, right? So our function, we're talking about the area, and represent by the A letter. So our function will say area. Remember the formula of area is pi r squared, right? That's the area formula, the formula of the area. So now we want to find dA over dt. And remember the chain rule in Leibniz notation, dA over dt will be equal dA over dr time with dr over dt. So when we cancel the dr on top here and the bottom here, we left with dA over dt, which is equal on the left-hand side. So this is the Leibniz notation. And now we can use it in this problem. And that's why I told you, usually I use white line, but sometimes we have to use the long notation in here. So in this problem, I'm going to use this notation of Leibniz notation. We want to find dA over dt equal dA over r times with dr over dt. And interpret as the derivative, the rate of change of area respect to time taken for each change happen, it equal the derivative area respect to its radius time with the derivative of the radius respect to time. So now let's do one by one, step by step. So I'm going to find the dA over dr first, right? So what is dA over dr? dA over dr equal, we're going to derivative this function, right? So this is dA over dr. Now remember the pi number, you can substitute by 3.14, right? But I'm just leave it for now. So remember this is not a variable, but this is just a constant number, right? 3.14. So we're going to take this derivative by bring it down in front. So it becomes 2 pi r. And that's it. We don't have any chain rule or whatever going on. So that's very simple derivative, right? So dA over dr equal 2 pi r to the power 1 instead of power 2. That's it. So now we find the dA over dr. So now we're going to work on what is the dA over dt? So our dA over dt will be equal dA over dr, which is 2 pi r. Let's rewrite it again so you can see how we substitute in time with dr over dt. So the rate of change of our area dA over dt will be equal dA over dr is, we work it out here, 2 pi r time with dr over dt. So at this point, we can substitute the value, right? Our dr over dt given by 3 centimeter per minute, so 3, so the value is 3. And now we can substitute the radius in here as well. So 2 pi, our radius is 6 centimeter, 6 times 3. So this become 18 times 2 is 36, right? 36 pi. And the final unit will be centimeter per minute. So that is the rate of change of the area. So this is dA over dt. And that is our answer for this problem. So this is a very typical simple problem I would like to put in here for the first time in our sequence of calculus, introduction to calculus course. But the next problem will be more step, involve more drawing, more geometry, more thing, right? So this is one typical problem. I would like to show you how we handle with that. Okay. So let me give you the summary a little bit, right? So the question asks for find the rate of change of the area when the radius of a circle is 6 centimeter. So on what we know, we assume that this is not this is a magic circle. It not stay still like that, right? It keep changing. So they said that over the time of change for 1 minute, the radius will, instead of 6 centimeter, it decrease to 3 centimeters. So this is a decreasing rate of change, right? Now the question asks for, so if this is the rate of change of radius, so what is the rate of change of the circle, of the area of a circle? So to use this, we have to establish a formula, a function, right? This is our function. It's like a y function, right? But this is the area function. And the area function based on pi r square. So now we will find the rate of change of the circle and find dA over dt. And we use the Leibniz notation. We know that dA over dt will be equal to dA over dr time with dr over dt, which is, we don't read like over like that. Actually, we read as derivative of the rate of change of area respect to time equal the rate of change area respect to its radius time with the rate of change of its radius respect to time. So now we solve dA over dr first. Using this formula, we can take derivative of this formula equal to pi r. And here, after we solve it, we substitute into we substitute the given value here into this equation and find out the final answer. So that is how we deal with derivative. So this is very simple, very straightforward again, right? So I hope you enjoy this problem. And I will show you in the next video, I will show you more complicated problem in the next video. Also, I will upload the file in our course, Introduction to Calculus course, to you before I publish out to the market. So I hope that you enjoy my course online, and I will publish on the Pre-Calculus 12, geometry, and so stay tuned for a lot of interesting stuff coming. And I hope you enjoy my teaching. Now I'm back with the whiteboard. I try to use a computer and using the mouse, but I feel very uncomfortable. Maybe I lack of practice, and I just found my teaching is so boring. So because I focus on using the mouse instead of showing you the step on the board. So you just have to be fed up with my big face, my big ugly face, to show you all of this stuff. And sometimes I might miss a part of it if I don't remember how to move the computer, and I'm sorry for that. I apologize for that. But working on a computer using the mouse sometimes it takes longer for me to draw on the sketching and thing. And I didn't have natural way of explain the lesson go through, so that it make you feel like my passionate about the subject and my activity like on the board, like natural. I stand in front of classroom and teaching on the student like this. So anyway, bye. Thanks for watching, and bye for now. So stay tuned for the next video coming. Again, we will work with some of typical problem solving, the application of our derivative in real life problem. So bye for now. Thanks for watching, everyone. Have a good day.